In order to see SSL in action, we go back to the browser, we type in our REST service, we go in using the machine name in this case, which has to be equal to the common name within the certificate, and we attempt to access the service now over SSL. We choose the port 8081 which we set up. Now we're going over SSL. We can prove that SSL is happening by clicking on the padlock within Firefox, and we see information about the certificate. It's not trusted because it's a self-signed certificate, but you can see that high-grade encryption AES-256 is being used for the connection now from the code within the browser back to the backend web service. So that means our AJAX requests now are going over SSL. So we have SSL in place for the encryption. Of course, that's just one level of security. We also use the content filtering to make sure that the data that's going over that encrypted connection is also valid and does not contain any threats. What we're going to do next is add further functionality in SSL by enabling mutual authentication. What this means is that clients accessing our REST web service now must present a certificate. We're going to say that the certificate issuer for the trusted connection to the SSL service is our REST certificate that we just created. So that means that we're now going to create a client certificate rule within the policy to enforce SSL authentication. This means that anybody connecting now to our REST web service must present the client certificate. We add that at the top. That's the first thing we're checking, if the user has presented the client certificate. If not, then they will be blocked from accessing the web service. You can see if you mouse over any of those, you see the inputs and outputs. Now if we go back to our web service and we attempt to connect without going over SSL, what will happen if we refresh the page is that we're blocked access denied. We're not allowed to connect to the service. What we're going to do now is create a client certificate which we're going to use for authentication at the browser. Again, we create the common name by which the client will be known. We're going to call this REST client. We don't have to put in all of the attributes here. We're going to put in an organization name as well. We'll see that later when we look at the certificate being used for client authentication. When we choose to sign the certificate, we're actually going to sign it with the public and private keys that we used before. So that then means that the certificate we created before becomes the issuer certificate. This maps with how we set up our demo, and in a real life situation, normally you'd be using a third-party certificate authority such as VeriSign or a corporate CA as being the trusted issuer certificates. Our REST client now is shown within the list of other certificates. We're now going to try to connect to the service over SSL. Our policy says that you must authenticate. We're asked here to choose the certificate to authenticate. This is the REST client certificate that we just made. We choose that certificate, and then that will mean that we're allowed to connect. Notice that's the REST client. And now we can connect. We're now allowed back into the web service, and we can use it. We type in the value, we get it, the value come back. We put in the SQL injection, and we see forbidden come back as well. Again, if we click on the Firefox settings, we can see information about SSL being used and the authentication in place there. Next, what we're going to do is add rate throttling to our REST web service. This is often used in the Web 2.0 area, whereby if you're exposing a service to the internet, you don't want people to use it in an unreasonable manner if they're using too many lookups against a search service or product lookup service, for example. We're going to say if there's more than 10 requests to this REST service in a minute, then we're going to block the messages. We also choose to cache the information, so if there's multiple XML gateways, they can all share that information. So if 5 requests go to one gateway, 5 requests go to another gateway, then we still know that there have been 10 requests in all, and we can block based on that. We're also doing the rate throttling depending on the identity of the client, which we've identified using a certificate. If If we block a client, we're going to then set the default handler to be a policy shortcut to sending back HTTP 403 forbidden. If we repeatedly click on the text here, we see access denied comes back. We have gone over the allowable number of connections. Looking back at our diagram, you can see the XML gateway is now providing authentication, SSL, threat scanning, and rate limiting for the backend REST web service. This is application firewalling for a REST web service. We look back at the agenda to recap on the various different items we've seen. We've seen what Rope 2.0 is, how the XML HTTP request object is used, and we've seen the XML gateway from Vordel in action. If you'd like an evaluation copy of the XML gateway, or you'd like to find out more, look at Vordel's website or contact info@vordel.com.
The increasingly open trading environment built on the internet presents companies with many opportunities and challenges. Rapid response is key to generating operational efficiencies, avoiding customer churn, and providing a positive end-user experience. The ability to control and monitor access to online services and enforce service-level agreements is mission-critical. In this open web-based world, companies need to have confidence and trust in the security framework underpinning every commercial exchange. And Vordel addresses all these concerns. Our products accelerate, manage, and protect services across corporate networks and cloud computing environments to enable companies